Hello students, welcome to my YouTube channel. In this video lecture, we are going to look at new questions from the chapter 1 of Keith Williams' Weight and Balance book. So let's begin with question number 141. What is the useful load if basic empty mass, crew and operating items, takeoff pass, usable fuel is so and so. So you all know the formula. Useful load equals to useful load equals to takeoff mass minus dry operating mass. That is equal to takeoff mass minus basic empty mass plus variable load. So takeoff mass is 142,000. Basic empty mass is 61,500. Variable load is 2,300. So 142,000 minus 61,500 plus 2,300 is 63,800. So that is equal to 79,000. So useful load equals to 79,000 kg. Next, what is the maximum mass of fuel that can be loaded on aircraft if capacity is 3,800 US gallon and specific gravity is 0.79? So specific gravity equals to mass in terms of kg divided by volume in terms of liters. So 0.79 equals to mass in terms of kg divided by volume in terms of liter. Now the volume given to us is 3,800 US gallon. So that will be equal to 3,800 US gallon will be equal to 14384 liters. 14384 liters. So 14384 liters. So mass in terms of kg equals to 0.79 into 14,384 into 0.79. So that is 11,363. 11,363 kg. Okay. Next. Which of the following documents should be consulted to obtain conversion factors to be used when converting fuel quantities to masses when actual specific gravity hasn't been provided by the fuel supplier, right? So which document will you consult? So you will consult the operations manual. In that particular document or in that particular manual, you will find how to convert or how to find out a particular fuel quantity in terms of kilogram, or if you want to find out the specific gravity is not given to you. So what procedure to follow in order to find out the mass of the fuel? Okay, you will be knowing, or you will know the volume of the fuel, so and so liters, and if you want to convert that liters into corresponding mass in the absence of center of gravity, the solution or the procedure to do that will be mentioned in the operations manual. Next, 144. The disposable load is what? So the disposable load is nothing but your useful load, which is nothing but a combination of takeoff fuel and traffic load. So loads which can be thrown overboard to reduce mass in emergency, DOM minus payload and fuel, all fuel and other consumables on board, passengers, their baggage, cargo, usable fuel and other consumable fluids. So correct answer is option delta. Passengers, their baggage and cargo will make for your traffic load. Usable fuel and other consumable fluids means your takeoff fuel basically. Okay, so delta. Next. Aircraft has a mass of 13,000 kg. Convert this in terms of pounds. Go to CX3. So weight. So weight is 13,000 kg, right? Now press the convert unit button. In terms of pounds, it is equal to 28,660. 28,660. So option alpha. Next. Where aircraft with nose wheel and two main wheels is stationary on the ground, that means it is parked on the ground, its mass can be considered to be a single mass acting through what? Acting equally through all three wheels, nose wheel, main landing gear, through center of pressure, through center of gravity, equally through the main wheels only. So correct answer is option Charlie, center of gravity. So this is your aircraft. Okay, it will have a nose wheel, it will have two main landing gears. Now the entire weight of your aircraft is said to be acting through one point called the center of gravity, right? So the correct answer will be center of gravity. So remember that. So center of pressure is the point where the lift acts. Center of gravity is the point from where the gravity or the weight of that aircraft will act. Next. When aircraft with nose wheel and two main wheels is stationary on the ground, its center of gravity must be halfway between the nose wheel and main landing gear, must be below the center of pressure, anywhere on the longitudinal axis between the nose and the tail, between the nose leg, that is nose wheel, and main wheels. So remember, your aircraft is stationary on the ground, correct? This part of the question is very important. Now, when your aircraft is stationary on the ground, let's say this is your ground surface, and this is the nose wheel of your aircraft, and these are the main wheels of your aircraft. Okay, so if the center of gravity of this aircraft is somewhere beyond the limits of this nose wheel and main landing gear, so somewhere outside this limits. So let's say center of gravity is here. Okay, outside these two limits. Okay, so if that is the case, the center of gravity is the point from where or to which the weight of aircraft acts. This weight will act downwards. That means the tail section of this aircraft will be pulled downwards and the nose section of this aircraft will be pulled upwards. Right? So that means this part of aircraft will be lifted above the ground or will be lifted from the ground, right? So this is not a safe condition. So when your aircraft is on the ground, it is very important that the weight of aircraft, okay, helps or enables this aircraft to remain stationary or to remain in contact with the ground surface. That will be only possible when the center of gravity is anywhere between the limits of nose wheel and main landing gear. So your center of gravity can be here. So in that case, the center of gravity will act downwards. The weight of this aircraft will act downwards. Okay, in this region of the aircraft. Okay, so this will enable that aircraft to remain in contact with the surface. So the correct answer here will be anywhere. It must be delta between the nose leg and main legs. Okay, so between the nose wheel and the main landing gear wheel. It's not necessary that it has to be between them exactly in the center. It can be anywhere between them. So therefore alpha will be wrong. Below the center of pressure, wrong. Anywhere on the longitudinal axis, no, not anywhere. Like I said, if it's anywhere on the longitudinal axis, like at this position, it will lift the front portion of this aircraft in the sky. So that's why we don't recommend that. The center of gravity must be in the limits or between the limits of nose wheel and the main landing gear. Next. 148. Which of the following statements are true? That means there are more than one statements which are true. Zero fuel mass is dry operating mass minus traffic load. Wrong. Zero fuel mass is dry operating mass plus traffic load. So, wrong. Zero fuel mass is dry operating mass plus variable load. Wrong. It's dry operating mass plus traffic load. Dry operating mass is zero fuel mass plus variable load. Again, wrong. Dry operating mass is basic empty mass plus variable load. Basic empty mass is zero fuel mass plus variable load, irrelevant. Traffic load is zero fuel mass minus DOM, yes. DOM is zero fuel mass minus traffic load, yes. So statements 5 and 6 are the right ones. So you will select that option which has these two statements in it. Next. The center of gravity of aircraft will be unaffected by passengers walking inside the cabin to and fro. That is wrong. The center of gravity depends on the weight of aircraft, that is the mass of aircraft, and the distribution of this masses in your aircraft. So let's say this is your aircraft, okay, and these are all the mass objects in your aircraft. So the center of gravity will depend on the total mass of all these objects and also how these masses are distributed inside your aircraft. Okay, so it depends on the total cumulative value and the distribution of this independent or individual objects in your aircraft. So as your passengers walk in the cabin, passengers or even the cabin crew, as they discharge their duties, they have to walk to and fro in the cabin. With their movements, the center of gravity is bound to be affected. Only that the affect the degree to which this affect the degree to which the center of gravity get affected will be very negligible. But yes, it has some influence on the movement of center of gravity. So option A will be wrong. Cannot move laterally because the fuselage is very narrow. Wrong. The center of gravity as your flight progresses from departure to destination, has the ability to move longitudinally between the nose and tail of your aircraft and also laterally, that is from wingtip to wingtip. Okay, next. It will remain unchanged provided fuel is used in the correct sequence. It will remain within limits in flight provided fuel is used in the correct sequence and cargo is secure. So delta is the right option. The center of gravity of your aircraft is bound to change, is bound to move within its forward limit and aft limit throughout the duration of your flight. If the center of gravity, so always remember the center of gravity position at the beginning of your flight will be very much different from the center of gravity position in the between your flight and towards the end of your flight. Why? Because the fuel in your fuel tanks will be consumed as you progress or as you start your journey from departure to destination. Okay. The only good thing or only the advantageous or positive thing about this is that the center of gravity has to remain or is made to remain within the limits, the forward limit and the aft limit, by following the correct sequence of fuel consumption as specified by the manufacturer. Okay, so it will remain within limits provided fuel is used in the correct order or sequence and cargo in the cargo section is properly secure. Okay, it should not move here and there. All the cargo must be tied and secure. Maximum allowable taxi mass is equal to maximum takeoff mass. Wrong. So maximum allowable taxi mass. Now this taxi mass will include taxi fuel as well. Correct? Takeoff mass will not include taxi fuel. Takeoff mass will include the aircraft mass when it is positioned ready for takeoff on the runway. And when it is on the runway ready for takeoff, the fuel in the fuel tanks is takeoff fuel, meaning fuel on board. And this takeoff fuel excludes or does not consider the taxi fuel. Therefore, taxi mass and takeoff mass are two different things. Depends on shock absorber pressures and extensions. No. Is determined by airport authorities. Wrong. Provides an allowance for fuel for taxiing to the takeoff brake release point. That means this taxi mass, like I said in the beginning, will include taxi fuel, and this taxi fuel will be used or consumed in taxiing your aircraft or moving your aircraft from the parking area, the ramp area to the runway surface. Okay, to enable aircraft to start the takeoff run at its maximum structural takeoff mass. So delta is the right option. So this brings us to an end of this lecture. I hope you have understood all the 10 questions I explained and answered in this video lecture. Keep practicing. All the best. In my next video lecture, I will come with some new questions from some new chapter in weight and balance. So do watch that.